Assalamualaikum warahmatullahi wabarakatuh and good morning. So today I want to continue an example for dynamic Hattenberg application on a 6 degree of freedom robot arm. So let's go. Before that, I would like to refresh what we already learned about dynamic Hattenberg. So there are 4 rules. The first one, which we want to assign frame on the robot if the robot doesn't have any frame. Okay, and then we want to find the DH parameter table, which we have 4 parameters that we need to find. Then we need to multiply the matrices, find the matrices first and do the multiplication. Okay, so in this case, in this example, the the frame is already there. We already have it in the diagram. So we only need to find the second one. So let's refresh about the second one. So as you remember, first we want to find theta. Theta is the rotation on Zn minus 1, which is this one, exists until xn minus 1, which is this one, is the same with xn exists, which is this one. So the rotation will be on this axis Zn minus 1. This is the example. So we want to rotate the Zn axis so that this xn frame here will be the same with xn axis here. So the frame and this is the axis. Okay, first what we do, we move these two frames together like that. And now we can see that this is the xn axis, this is the xn minus 1. So we want to rotate by using, this is our thumb and this is our finger. So this is my palm, looking like this. So I want to do a rotation in this direction. So this is the positive direction. So here the rotation will be in this direction. So we will move about 90 degrees so that the xn minus 1 will be the same with xn axis. So now we get the theta is equals to 90 degrees. So that one is easy. We also need to remember if the Zn minus 1 is a actuator, which means it have a motor. Therefore, we don't need to determine the theta value. We just put the actuator theta for this part is just theta is just equals to theta 1, because the theta may change as the actuator move. So now we go for the second DH parameter. The second DH parameter is D. Note that we are still using the Zn minus 1 axis, which is this axis. And this is Zn. We want to move the center, which is the center of Zn minus 1 frame, so that the center of the frame will be same with frame n. So this is frame n and this is the center. We want to move in Zn direction, which is Zn axis is this way. So we want to move this way, going up, so that these two n will have the same position. So to do that, we just need to move the center of frame n minus 1 up so that it will become same with frame n. Now the distance of this movement is called dn. Next, we want to find the parameter for an. Note that in this case, we need to move along xn axis. So previously we are using Zn minus 1 in this case we are using x and axis. So we are moving following the x and axis. Where is the x and axis? So here. So we are moving along this way. So what we need to do is we need to get the center of frame N1. So this is the center to be the same with the center, and the movement is along this way. So to do that, we just need to move this direction. And what the distance that has been traveled, which is AN, is the distance for AN parameter. Now we will move to the fourth parameter, which is alpha. Note that alpha is the rotation on xn axis. So where is our xn? It is this one. And we want to rotate the xn axis. So first I want to delete some of this first. Okay. So now this is our finger, and this is our other finger, and this is our palm. So we want to rotate in this way. So if we want to rotate in this way, so what do we want to rotate? Why do we want to rotate xn? We want to rotate xn so that zn minus 1, which is this axis, should be the same with zn axis, this axis, zn. To do that, we need to bring the n minus 1 axis to the same place as the zn, and then we rotate using the xn axis, which is this one. We rotate so that the zn minus 1 will be the same with zn using this way rotation. So in this direction, we can see that we are going through on the back here, we are turning positive 180 degrees. So alpha is 180 degrees. We can also say that alpha is negative 180 degrees. It is also true. Now we want to test, we will have the DH parameter, and from this DH parameter we will fill in a DH metric as given above. So this is AN, so AN is this one. Sorry, this is DN. So this is DN. So DN is this value here, and AN is this value here, and alpha n is this value here, 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 and theta is this value here, 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 here. Okay, so we need to fill in all of the parameter inside the DH matrix, and then we get a DH metric for one frame. Later on, I will show one example for the 6th degree of freedom robot. So now we have a Puma robot. It is a 6D OF robot. Let's see all of the degree of freedom. So this is the frame 0, and this is the rotation for frame 0, which is theta 1. And then we have frame 1 here, and the rotation for frame 1 is theta 2. Then we have the frame 3 here, the rotation is theta 4, and frame 2 here, the rotation is theta 3. So now we have 4 theta, which means we have 4 degrees of freedom. Now we go to the wrist of the hand, which is this part. So here there are one rotation on frame 4 here. The rotation is theta 5. So which means we have 5 degrees of freedom. Now the last movement is a rotation on the wrist like this. So this is on frame 5, and the theta is theta 6. So this rotation will be 6 degrees of freedom for this robot. So now we need to find all of the frame for this robot, which is we want to find for frame 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So we want to find all the DH matrix on this part. To do that, we need to find the 4 parameters. So first, let's find the frame 1 parameter. So frame 1 parameter, we need to find the rotation on n minus 1. If n is equal to 1, so 1 minus 0, so if we want to find Zn n minus 1, so the rotation on Zn minus 1, so because of n is equal to 1, 1 minus 1 is 0. So the rotation that we want to see is the rotation of Z0. So we have an active motor here, and the value is theta 1. So which means we just need to put it as theta 1. Next, we want to find the D. Now we want to find the parameter for Dn, which is D1. So Dn is the movement for which axis? Yeah, it's still the same, which is Z0 axis. We want to move the point of frame 0 here, so that it will become same with point frame 1, and the movement is along the Z0 axis. We can see here both of these points are at the same position for Z, so there is no movement in terms of Z0 axis. So D will become 0. Next, we want to find the rotation of x1, so that the Z0 here will be the same with the Z1. So the rotation will be on the x1. So An is the movement along the x1 axis. So this is the x1 axis. So we want to move so that the middle frame of 0, it will become the same with frame 1. But we can see here both of the frame are at the same position, so we don't need to do any movement. Therefore, A1 is equal to 0. Finally, is alpha 1. Alpha 1 is the rotation of x1 axis. So we want to rotate this way. So this is the positive rotation. So we want to rotate so that the Z0 will be the same with Z1. So the Z0 is this way, and Z1 is like this. So we need to move in a negative way. So it is negative rotation, negative 90 degrees. So we get negative 90 degrees for alpha 1. Now we're going to solve the other parts. So the next one is for frame 2. To do this, we need to find the rotation on Z1. So this is our Z1. So let me erase all of this first. So it will make it easier for us to see. Okay, now we need to move in Z1 direction so that the point of frame 1 is the same with frame 2 here. So because we are moving backwards. So this one will become the same, and so the distance between here and here is actually d2. Okay, sorry, made a mistake again. It is true, it is d2, but we are not talking about that first. We are talking about the rotation of theta. So theta is the rotation of z1, because z1 has an actual motor which is rotating this way. So the theta for z1 is actually theta 2. So we just need to put theta as theta 2. And all the theta will be theta 3, 4, 5, and 6 until 6, as we have discussed before. Now, the problem is to find the d2 here. So the d2, we need to move this point here along z1 direction so that it will become the same with here. Okay? Because there are some constraints in terms of the drawing, the actual meaning is this one is the same here. So the distance moved along here is actually d2. So we get the d here is actually d2. And this value should be, in terms of this figure, this value should be negative. But we note that the negative value can be inside d2. Next, we will go to the an. Where is the movement for an? An is the movement for x2. So x2 is moving like this here. So we want to move frame 1 so that it will become the same with frame 2, and the movement will be along x2. So first we want to find this distance. So here is the distance. From here to here, the distance is actually a2. So the answer here is a2. Now we're going to find the rotation for alpha. So rotation for alpha is also simple. We just need to rotate the x2 so that the z2 will be the same with z1. And we can see both are at the same position, so there is no rotation, so it is 0. Now we move for theta 3 here. For frame 3, we can see that the z2 axis here have a rotation of theta 3, because this is a motor and the robot move, so we just put it as a variable of theta 3. Next, we want to find the d here. The d is the movement along z2, so that the point of frame 2 is the same with frame 3. So we can see there is this movement here. Okay, so this movement here is called 0, because actually both of these points are at the same point here. They just put frame 3 here just to show that there are two frames at the same position. So it's a little bit confusing, but this is equals to 0. Okay. Now we want to find the movement along an. So for an, we want to find the movement for x-axis, which is x3. So x3 is going down. So we want to find so that these 2 points will become the same. Note that these 2 points are at the same position, therefore it is 0. Finally, we want to find the alpha, which is the rotation of the x3 axis in this way, so that the z3 will be the same with z2, or we need to move z2, so it will become the same with z3. So I use blue color here, and this is our z2, so we need to move 90 degrees so that it will become the same with z3. So the answer will be 90 degrees for alpha. So now we have solved until this point here. So let's continue. Just need to clean everything. So let's continue. Okay, now we are going to do the rainfall. So because of we need to find theta is zn minus 1 is if n is 4, so the z will be z3. So here, so we want to rotate the z3 here. We can see that there is a active joint, which is theta 4, which is active actuator or motor moving here, and the variable is theta 4. So theta n will become theta 4. Next, we want to find the parameter of d. So for d4, we need to find the movement of z3. So we want to move z3 so that this point here will become the same with frame 4, which is this point here. So the distance is here, given here. So from here to here, which is d4. Next, we want to find the a4. The a parameter is the movement for x4 here, so that this point here, frame 3, will become the same with center of frame 4. So we can see that both of these are in the same position, so we don't need to move, we don't need any movement in terms of x4 this direction, so it will become 0. Now we want to to find the alpha 4, this one. So alpha 4 for this one is the rotation for x4, so that the z3 will become the same with z4. So I want to use blue color to show the z3. z3 is like this. Sorry. And the rotation will be in this way here. So this direction, oh sorry, the direction, yes, it will be on that direction, but we need to move from z3 to z4, so it will become counter the direction, so it will become negative. So what we will have is negative 90 degrees. Okay, I want to clean everything again. Also, okay. Now we want to go to the frame 5. We're almost there. We are almost there, guys. So here. So what we need to do is we need to rotate z4. So there is an active rotation here, and the value of variable is theta 5. So we just put theta 5. Then we want to find d. First, we need to move the z4 so that this point here will become the same with this point. And in this figure, actually both of this point or this frame are at the same position, which is here. So therefore it is 0. How about the an? the AN is the movement of x5, so that this point here will become the same with this point here, and we know both are at the same position, so it should be 0. And finally, we want to find a rotation of x5, so it should be this way, the rotation, blue color for Z4, so Z4 is looking this way. So because our rotation it is from here to here, so we have a movement of 90 degrees, so alpha is 90 degrees. So let's go for the last one, the last frame, which is frame 6. So frame 6, so we want to find the Z5 rotation, so we have an active motor here which is theta 6, so we just put it theta 6, and then we have the movement from this point here to here, and this movement in Z5, and the movement is equals to d6, which is this distance here, from here to here. Okay, so this small distance is d6, so it is a distance between the joint of the wrist and the end of the manipulator or end, which is here. So from the joint, which is this one here, to here, that distance is equals to d6. Okay, now we want to find the A6. The A6 parameter is the movement along x6. So do we have any movement from this point here to here? There is no movement, so 0. And also for alpha 6, it is the rotation of x6, so that the z6, z5 will become the same with z6, and we can see both are the same, so it is 0. Now guys, we have completed the DH parameter for a 6 degree of freedom Puma robot. Now we want to find the matrix. So first, what we do is we need to fill in all of these values into one matrix. So the first one will become T n minus 1, which is 0, n, which is 1, and we need to fill in everything here. So we can see here, we need to fill in theta n. Here is all of the theta n. Then we need to fill in Bn. This is Bn, An, and alpha n. So it's just a simple fill in value, and we will get a matrix. Then we will get a T01, T12 until T56. So finally, what we need to do is we need to get the DH matrix for T0 to 6. So we need to multiply T01 multiply with T12, and then we need to multiply with T23, and then we need to multiply with T34, and then we need to multiply with T45, and finally we need to multiply with T56. Then we will get this metric. So this metric will become our forward kinematics matrix, which means if we put in all the these 4 parameter value, or we just put in the theta value of the robot, we can find where is the robotic arm and position. So now we want to find the T06, so we need to multiply T01, 02, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So here we want to do this part. So this is T01, T12. You can see when we multiply 01 into T12, so we will get a transformation from 0 to 2. But the end we want to from 0 to 6. For this part, we just need to put in the DH parameter inside the DH matrix, and we will get these two matrices. Then we need to multiply all of these matrices. So to do that, first we take all of these parts and multiply it. So this one, we need to multiply this one, c theta 1 with c theta 2 will become c theta 1 and c theta 2. And this one with 0 to 0, and this one with negative, this one is 0 to sine theta 2, and this one will go to negative sine theta 1 with 0, and this one with 0 and 0. So the answer plus 0 plus 0 and plus 0. So this will become our answer for the first one. Okay. Still, I think currently it's still okay. So now we're going to find the next metric, which is this one. So we want to multiply this with this part here. So here cos theta 1 with negative sine theta 2, we will have negative cos theta 1 sine theta 2, and this is 0, 0, and this is sine theta 1 with negative 1, and finally 0 with 0. So this will become cos theta 1 sine theta 2 minus sine theta 1 here. Next we will go for the third part here. We multiply this one with this one, so we will get this part here. Because everything is 0 on this part, so it will become 0. Next, we want to multiply this one with the final one here. Okay, so cos theta 1 with a2 cos theta 2, so we will have this one here, and 0 with a2 sine theta 2 becomes 0, 0, 0, and 0, 0. So what we will have here is just this one here. And then we can continue the other parts. For this one, we just continue the same thing, multiply this one with this one, we get this one, multiply with this one, we get this one, multiply with this one, we get this one here, and multiply with here, and we get here. And we just continue all of this multiplication until here, and we get all the answer for T02. Then we will continue for the next slide. We want to find the T03, so we need to multiply T02 with T3, 2, 3. So here is 0, 3. So we will have it like this. So this is T02 here and T32 here. So we do the multiplication and we get this answer here. We continue with T304, which is 03 with T34. So this is 0334 multiply and we get T04. Continue again. Yeah, it will become much bigger. T05 is the multiplication of T04 with T45. It's 4, 4, 5. So these two will go here. So that's how we can get the transformation T05. So we need to multiply T40 to T45, do the same multiplication, and we get this metric here. And finally, we want to get the T06. We just multiply T05 with T56, and you guess correctly, and we will get this answer here. So this is our final matrix. So thank you very much. So that's all for our class today.